Hi everyone, I'm Miss Felicia teaching from OVERMUGGED Bukit Timah outlet today. So for the lesson today on Sec 3 Pure Chemistry, this will be the topics that we'll be doing. So firstly, I will need you to go to OVERMUGGED O-Level Telegram group chat. Can you go over there to download the lesson worksheet? So the link to the lesson worksheet that is shown over here, this worksheet, that is actually in the Telegram group chat. Alternatively, I have actually also sent the lesson material link into the Zoom chat, so you can actually also download from there. Okay, so before I begin, let me just give a little bit heads up on like what can you expect for the lesson for today. Okay, so just to share a little bit with you all, in case like you all have never heard of like this tuition center OVERMUGGED before. So for OVERMUGGED, the teachers here, we are all very young and dynamic teachers, but although we are young, it doesn't mean that we are not experienced. So all of us have been actually teaching for many years already. And that for OVERMUGGED is actually a tuition center that focus mainly on secondary school and JC. So we do have classes for O levels like you all, IP as well as A levels. So for OVERMUGGED, here are our branches. So right now, where I'm hosting at is actually at Bukit Timah. Then we also have the new centers at Marine Parade as well as Serangoon. But besides our OVERMUGGED branches, we also do teach at other places like Toa Payoh, Jurong East, Woodlands, and soon up and coming, it will be Tampines. Okay, so just a little bit self-introduction about myself. I do teach secondary level, so I teach O levels as well as IP stream. I teach all three sizes. So here today, I will be teaching you chemistry. So for my track record, it has been like students has been scoring very well. They have been scoring a lot of A's. And even for IP students, they also do well in exams too. So previously, I was actually from NTU and I graduate from the degree in science. So I majored in science and that's why I'm teaching science right now. So I teach IP and O level, upper sec and lower sec, all three sizes. So previously, before I joined OVERMUGGED, I was actually in the Learning Lab, another tuition center, and I was teaching like for the past 7 years till last year. So actually, I just came over to OVERMUGGED this year. And that for before at the Learning Lab, I was also teaching at the Wasteland Tuition Center. Then even earlier on, I was also doing like MOE relief teaching at the various secondary schools. And then even earlier, I was like doing like private tuition. So so what will we be doing today? So as you can see for the lesson material for today, it will be mainly one page of notes to recap the most important concept in the entire chapter, as well as we will be identifying misconceptions. So it's like mistakes that your friends might make. Today, I'm going to highlight to you so that you don't make the mistake that your friend might make. And then how to approach them. And for the difficult questions, I will guide you step by step on how to approach it, how to tackle it. So that you know, like in exam, if you meet such difficult question, then how to like go about solving it. And the questions that we are doing today are the commonly tested questions, which will often come out in exam and hopefully it come out even in your end of year exam. And that we'll be also teaching you like answering techniques on what are the keywords that are required for like open-ended answers. And that so today we'll also be having worksheet practice questions. So we'll give it a try to see whether like you can answer it or not. So let's make our most productive 2 hours ever today. So let's begin now. Okay, so so here's the worksheet. So for those online who just came in, just a reminder to download the lesson material from either the OVERMUGGED O-Level Telegram group chat, or you can download from the Zoom chat. So let me just send it again in case those who came in late couldn't receive it. Okay, so for the first chapter over here, experimental design, been I think quite a while ago, right? It was like the January topic this year. So for this topic over here is mainly you need to know like how to like collect the different gas. So there are 3 methods: displacement of water, upwards delivery, and downward delivery. So for displacement of water, upward delivery, and downward delivery, how do you decide like which method to use? So first, you have to check whether is the water soluble or not. Is the gas soluble in water or not? So if the gas Oh yeah, by the way, just to let you all know that for my lesson style is whenever I highlight and I write on the lesson material, you follow and do so too. Okay. So for the gas, you need to decide whether it's soluble or insoluble. So if it is soluble, then you should do the upward and downward delivery. So maybe let me write like that. So if the gas is soluble, you should either do upward or downward delivery. But if the gas is insoluble, you do displacement of water method. So usually the first step is you check the gas, is it soluble or not? Yep, so for gases that are insoluble, the common examples would be hydrogen, oxygen, carbon dioxide. So once you see hydrogen, oxygen, carbon dioxide, you need to know that they are insoluble. That's why you can let it pass through water and then like get collected on top. Then next is if the gas is soluble, then you will not pass through water. If not, the gas will get trapped inside the water, right? Yep, so that's why if it's soluble, you either do upward or downward delivery. How to decide? It depends on the density. So for density is that how do you know like NH3, is it dense or not dense? Then if it's like HCl, is it dense or not dense? You are not required to remember, okay? So you don't need to go and memorize it. There is an understanding method to do it because science, there's too much thing to memorize already, right? If this kind of thing also need to memorize, then I don't think your brain got capacity anymore. Okay, so how do you go about doing it? You go by the MR, which is the mass. That means you check the periodic table for the mass number. So if you check that, because you know that in our air over here, the air that we breathe, it is majority nitrogen gas. So nitrogen, can you check your periodic table? I don't think my booklet has periodic table. Yeah, but oh yeah, I have at the end. Yeah, so it's on the last page. So can you check for nitrogen gas, which is the most abundant air in our gas, our air here, the most abundant gas in air. Can you check and tell me for nitrogen, what is the mass? So can you look at the mass number? So the N you add together, how much is it? What's the mass of nitrogen? By the way, I will need a response from you all, okay? I'm not going to do a monologue. Yeah, so how? What's the mass of nitrogen? Are you checking the periodic table? Can you check and let me know? For those online, you all can participate too. You can type it in the Zoom chat. David, a bit of, you check periodic table for nitrogen, what's the mass number? Yeah, thank you, Madeline. Yep, the answer is 28. Because if you check periodic table, nitrogen is 14, and then there's 2 nitrogen. That's why the answer is 28. Yep, so that's why in this, what you need to do is that because our air here is not only nitrogen, it's just majority nitrogen. So there are still other gases. So the mass, it will kind of be close to nitrogen. So you can also use like 28 as a gauge. Yep, so as long as the mass is smaller than 28, like for example, if you calculate for NH3, if you calculate the mass, and we mentioned that it is 14 above, right? So it's 14 plus 3 times 1, this is 17. So since 17 is lighter than 28, lighter means less dense. Less dense means float. Yeah, because density, the formula is the broken heart shape. Can you see over here? There's the heart shape, the M and the V. Yeah, then there's a line across it that so it's like broken heart shape. Yep, so generally is that the lower the mass, the lower the density. So that's why if the mass is smaller than nitrogen, considered as less dense. Then let's take a look over here. So maybe like if you look at maybe chlorine. So chlorine, what's the mass? So can you check the periodic table and tell me again, what is the mass of chlorine? Cl2. What's the mass? Yep, thank you, Madeline. Yep, it's 71. Because you take 35.5 times 2, then you get 71. Okay, so then in this case, you look at the number, 71 is bigger than 28, right? That's why more heavier, that's why it's more dense. So that's why you see there's no need to go and memorize every single one. Is it more dense or is it less dense? After a while, if you go by memorizing, right, you'll get confused. Just calculate. The periodic table can give you the answer. So why memorize? Yeah, so this is the trick. Okay, then next it would be drying of gases. So take note that these 3 substances can help to dry gas. And take note that it must be concentrated. Because if it's like dilute, usually it will be like involved, in the chemical reaction, like in acid bases. Yeah. So for solubility to determine it, this one have to remember it. There is no shortcut like periodic table numbers to help you out. Yeah. Okay, so then continue on to the next one. Okay, so for concentrated H2SO4, because this is actually your sulfuric acid, that's why it is to dry acidic gases. Cause sometimes question might ask you, if I say that I want to dry maybe ammonia gas, so then they ask you, can you use concentrated sulfuric acid? Then what do you think? Even dry ammonia gas. So the answer is cannot. Why? Because instead of drying, ammonia is actually alkaline. So if you use H2SO4 and expose to alkaline, acid and alkali, they will actually react and form neutralization reaction. Yeah, so that's why you must take note that what is the pH of your gas. So it's not like any three of them can dry any gas. No. Acidic stuff can only dry acidic gas. Alkaline stuff, then can dry alkaline gas. So then if it's CaCl2, this is actually neutral. Yeah, so that's why it is able to dry most gases. Okay, so just to check for those online, are you all done noting down? So once you are done noting down, can you click the reaction thumbs up button to let me know? Then I'll move on. Are you all done copying? If done, thumbs up. By the way, while waiting for the rest to finish copying, I would hope that like you respond to me whenever you know the answers, because if you keep on like wait and wait and wait, then after that behind chapters, then I won't have time to finish up. Yeah, so whenever you know the answer, I'll strongly recommend that you participate. Okay. Okay, so I think I shall move on. So for those online, if you are not done, can you take a screenshot or you take a photo? Then I'll be moving on. So then Brandon is asking, for neutral gases, we can use all of the drying agents. Yes, because neutral gases won't react with acid, won't react with alkaline. So yes, you can use any of the gases. Okay, so moving on. Okay, so over here, there is an MCQ. So can you all give it a try for this page and the next page MCQ? So there's 3 questions. Can you do it now? Then once you are done, then I'll be going through the answer. So do it now. This page and next page, 3 questions. To answer Jake's question, the more common ones are like what you mentioned, hydrogen, oxygen, carbon dioxide. Yeah, that you need to know. So as long as you know the more common ones, it is sufficient already. Yeah, so these are the ones that you should know. Okay, so for those online, once you are done, can you click the raise hand button? You know that there's this raise hand symbol, right? Yep, so you click the raise hand button when you are done. So when majority of you are done, then I'll move on to go through the answer. Joshua, yes. That's why if you look at the notes, we not only label it as insoluble, there's a slash sparingly soluble gas. You can see it? So Kaylin is asking how to know if the gas is neutral. You can go by the chapter of the acid bases, you know, the acidic oxide, neutral oxide, basic oxide. Yeah, so you can actually go from there. So that means generally okay, maybe I write it down. So for the gases, if they are acidic oxide, this is in the topic of acid bases, acidic oxide, it will be actually non-metal oxides. Then for alkaline, that means basic oxide, it will be most of the metal oxides. So that's one way that you can deduce. But of course, need to know that for non-metals, there are 3 exceptions. Yep, it will be NO, H2O, and CO that is neutral. Then for metal oxides, there are also 3 exceptions. Al, Pb, Zn. Yeah, these are amphoteric oxide. Yep, so you can use this general guideline. Then the rest that is like not oxide, like maybe ammonia gas. And this kind you need to like learn from the chapter that, in the topic of acid bases, alkaline is like a neutral, is a alkaline gas. Yeah, then like oxygen, this kind is like, it's not combining with metal or non-metal, then need to know that oxygen is generally neutral. Yeah, so some you still need to like have the general knowledge and know it. If not, the rest you can just base on this. Is it metal or non-metal oxide to decide the pH? For this worksheet, you can download it from the OVERMUGGED Telegram group chat, the O-level Telegram group chat, or the lesson material link is sent above, but maybe because maybe you come in a little bit late and then you miss the link. Yep, so I've just sent it out. Yeah, I just sent it to the Zoom chat. Yeah, so you can download from there. Then for those of you who are done, would you want to like copy this down to like note it down? Maybe let me modify a little bit so that it's easier to see. So for gas, usually you can check whether the gas inside, does it have metal or non-metal? So as long as they are non-metal oxides, then they can be either one. It can be acidic oxide or it can be neutral oxides. Yeah, so neutral oxide, it will be these 3. So let me shift this 3. Then if it is metal oxide, then it will be basic or amphoteric. Then it will be these 3. So meaning you go by metal or non-metal. For Madeline's question, are all oxides gases? No. Because it depends on the solubility. Yeah, so some of them may not be gas, some of them might be solids. So generally, how to know what are the oxides that are gas and what are the oxides that are solids? You can use chem bonding to help you. So that means if they are in covalent bonding, like non-metal and an oxide. So oxygen is non-metal, right? Okay, so maybe I write it down over here. A good question from someone online. So they are asking, are all oxides gases? Then the answer is no. Yep, because it depends. If you have a non-metal, like maybe carbon, you combine with oxygen. So this is non-metal and non-metal. So isn't this covalent bonding? And then in chem bonding topic, you learn that covalent bonding have low boiling melting point. So if they have low boiling melting point, that means they will be gas. But then if you didn't take a non-metal combined with oxygen, maybe you take a metal that combined with oxygen. Okay, let me shift this up a bit, no space to write. Yep, so if you take a metal, then you combine with oxygen. This time round, it is metal plus non-metal. Metal plus non-metal, isn't this ionic bonding? So ionic bonding, you learn that it has high boiling melting point, right? So if it has high boiling melting point, that means it will remain as solid at room temperature. So that's how you decide whether are the oxides gases or not. Okay, so for those online, are you all done with the 3 MCQ? How come taking so long? I think I shall go through the answer already. Are you done? If done, can you click the raise hand button? Then I can review the answer. Remember to click the raise hand button because if you just now click like the thumbs up button or other reaction button, it will disappear after 3 seconds. Then I won't be able to keep track. Yeah, that's why I must like choose the correct symbol, the raise hand. Okay, so since for those online, like more than half of you have completed, so I shall review the answer now. So those of you who haven't finished, then maybe you want to like copy down the answer somewhere, then you can reattempt it on your own at home. Okay, so let me now show you all the answer. I take it that you are done noting down all these annotations. Okay, so I shall clear the screen in 3 seconds. If you're not done, then maybe you take a photo or you take a screenshot. Okay, so 3, 2, 1. Okay, moving on. Okay, so yep, over here, this is the answer. Okay, so for the question number 1, answer is C. Moving on, question number 2 is D for dog. 3 is D for dog. Okay, so can you all let me know which question number would you all like me to go through? 2. Any more? Only question 2? Question 3, 2 and 3. Okay, so I'll be going through question 2 and 3. If you need question 1, you let me know again then. Okay, so for question number 2 over here, a gaseous mixture of oxygen and carbon dioxide was passed through X and Y, and they want dry oxygen. Okay, so that means at the end, you must make sure that you have oxygen. That means you need to get rid of carbon dioxide, correct? So what thing will react with carbon dioxide? You should know that lime water reacts with carbon dioxide, correct? Yeah, because lime water and carbon dioxide, they will form the white precipitate, and the white precipitate will end up be stuck inside this part, this liquid over here. Yep, so that's why you should choose lime water. Then on the right side over here, since they mentioned the word dry, dry means we need to use drying agent. Yep, so for the drying agent, then in this case, you have the sodium hydroxide. Sodium hydroxide is not a drying agent, right? Because if you check the notes over here, the drying gases, it is these 3. Sodium hydroxide is not in this list here. So you should choose concentrated sulfuric acid. Yep, so that's why you should choose the sulfuric acid. So that's why it should be this. So that's why answer is D. So for those of you who got this question wrong, can you like note down all the explanation? Yeah, so that you know like how to derive the answer on your own in future. Madeline, because you check the first page of the notes, under the section called drying of gases, there is concentrated sulfuric acid. Sulfuric acid is H2SO4. So sulfuric acid is a drying agent. Okay, so moving on, question number 3. So over here, they said that the apparatus is used to prepare carbon monoxide. And they show you that you start from carbon dioxide, CO2, then you must end off with CO, carbon monoxide. And that there is also carbon, C. So what is the purpose of the aqueous potassium hydroxide? So mainly is that if you only want carbon monoxide, means at the start, if I got any like residual carbon dioxide, I need to get rid, right? If not, if the carbon dioxide keep on travel, then get out, I might have carbon dioxide. That's why potassium hydroxide, this is metal hydroxide. Metal hydroxide is alkali. Yep, so need to know that this is alkali. So this is from the chapter of acid bases. Yep, so if you feel that you need a revision on acid bases, you can actually join us for the chemistry revisions session 2. So today's session 1, we are not covering acid bases. It will be covered in session 2. So session 1 topics and session 2 topics are different. Okay, so in this case, for potassium hydroxide is alkali. And then just now remember I told you, non-metal oxides are acidic. Yep, so that's why there will be neutralization reaction. Yep, so that's why the answer is D, to remove traces of carbon dioxide. Yeah, so mainly it's just neutralization reaction. You can write in the explanation here. like that. Okay, so moving on, should be done annotating by now. If you're not done, you take a screenshot then. 3, 2, 1. Okay, moving on. Okay, so moving on to the next page over here, it will be the separation techniques. Yeah, on like what are the different techniques. So usually when you study, right, I think schools will always teach you like one by one by one by one. But when you study, right, you don't study one by one by one. Why? The reason is because usually worksheet questions, they always ask you like, I have substance A, B, C, or maybe like I can say I have like iron filings, I have salt, then I have sand. Then if I give you these three, then how do you separate them? Yeah, so usually if they give you like 3 substances, if you learn individually, then how you know which one it is? So that's why you always look at it as an overview. Okay, so at the top, I think there's some space. You follow me and write it down, but try to write with smaller handwriting because what I'm going to write is quite a lot of stuff. Okay, so first is usually if it is a solid liquid mixture, so that means I have like solid liquid, maybe like salt in water, sand in water, sugar in water. Yep. So this kind of scenario is that first, it depends on what is the thing that you want. Do you want the solid or do you want the liquid? Yeah. So if you, and that whether it's the solid soluble also. Yeah. Okay. So if your solid is if your solid is insoluble, okay, change to soluble. Yeah. So if your solid is soluble, versus if your solid is insoluble, then what method to choose? Insoluble, I think is very straightforward because insoluble is just filtration, right? Something like sand in water. Sand cannot dissolve. Yep, so that's why you do filtration. So it's very straightforward. So done. So this is how you decide on filtration. Next is if it is soluble, there will be 3 different methods. It will be simple distillation. Then there is also crystallization. Then there's also evaporation to dryness. So out of these 3 methods, how do you further differentiate? Like, maybe I have salt water. So salt is soluble, but then salt water, how do I know which method to choose? So you have to read the question. Do they want you to collect the solid or do they want you to collect the liquid? Yep, so let's write it down. Want the liquid or do you want the solid? So if you want the liquid, it will be very straightforward. It will be simple distillation because simple distillation is where like you heat the salt water, then after that the water will boil and become steam, then it will travel up towards the entrance of the condenser, go into the condenser and then collect out as distillate. Yep, so that's why for simple distillation is to collect the liquid. And usually the liquid that you collect, it will be very pure. So we will call it as a pure distillate. Yep, so that's how you decide when to use simple distillation. But if you want the solid, like maybe salt water, I don't want the water. Salt water, I want the salt instead. So what method do you choose? So between these 2 methods, so now I only left with crystallization and evaporation to dryness, right? So between these 2, how do you decide? You check whether do they decompose or not. Are they thermally stable or unstable? So if they are thermally unstable, that means they will decompose, then you should do crystallization. Then if they don't decompose, then you should choose evaporation to dryness. Then I think you all should know that one of them is like you heat until like saturated, then one is you heat until totally dry. So how to remember which is which? So you base on the name, they say evaporation to dryness means it's totally dry. That means you really blast your Bunsen burner until it's totally dry. But for crystallization is that they never say dry, right? That means crystallization is still wet. That means crystallization is where you're supposed to like heat until you get a saturated solution. So saturated solution means that it's something like Milo dinosaur like that, is that no more solid can be dissolved anymore. So the solid is still like remain solid. So how to test whether if a substance is saturated? So usually is that you take the glass rod, you know, there is this stirring glass rod. So what you do is that you dip in and then you take out. If the glass rod, there's still like small little dots on it, like solid, that means it is saturated. But if you dip in and out, it's like totally just liquid, right? Like example, now if I dip it into my water bottle and take out, it should be just smooth, just water droplets. So if it's just water, that means that one is not saturated yet. So that's how you test for saturation. Okay, then answering questions from online, you all ask how do you know if substance will decompose or not? So need to know the common examples. So for maybe you write it inside. Where's crystallization? Crystallization, I think is below. Okay, maybe I write down at the bottom just to check. Are y'all done like noting this down? Can I move on? Okay, so if you're not done, maybe you want to take a screenshot, then I move down now. So I move on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so let's write down the examples that will decompose. Crystallization. Oh yeah, it's over here. Oops. Okay, so for crystallization, I think no space on the left, I write on the right side. So need to know the common examples would be copper 2 sulfate, the blue color crystal. Remember in school experiment, like the lab, you all collect the blue crystals, right? I think most schools should have done it. The blue thing is actually copper 2 sulfate, as well as sugar. Because sugar, you can heat it and then become caramel, right? Caramel can become like totally black. Yeah, so that's why sugar will decompose. Then evaporation to dryness, the common example, it will be salt. The salt that we use for cooking, eating, NaCl. Okay, then let's continue to write down some more examples. So the common examples that school like to test would be filtration. They usually put sand. Evaporation to dryness is salt. Crystallization is copper, sulfate, and sugar. Sublimation, it will be iodine. Mothball. Mothball is actually known as this chemical name called naphthalene. Yep, as well as dry ice. Dry ice is not water. Dry ice is actually solid carbon dioxide. Yeah, so these 3 are common examples of sublimation. So once you see iodine or like naphthalene or like solid carbon dioxide, once you see these 3, choose sublimation. Then next is for simple distillation, common example, it would be like salt water. Yeah, that means you remember based on the flowchart on top, fractional, a simple distillation is that you want the water, you want the liquid, not the solid. Then next is for fractional distillation. Fractional distillation, it would be to separate liquids. Yep, so take note that fractional and simple, although the name like very similar, the thing they separate is totally different. For simple distillation, they separate solid liquid. Remember, just now at the top left, we wrote down, right? Solid liquid mixture separation. So that's why simple distillation is to separate solid liquid. But then for fractional distillation is to separate liquid. So take note, okay? So how do you decide simple or fractional? You go by the states. Yeah, so if you're separating 2 liquids, like maybe oil, not oil, maybe like different types of petrol. You know, you dig the petrol out from the ground, then you separate them. So that will be fractional distillation. So the common example, it will be crude oil. Because crude means you just dig out from the ground. You haven't separate yet. Okay, then next is separation funnel. Separation funnel is also for liquid separation. So how do you know when both are liquid? Do I use fractional distillation or do I use separation funnel? So again, same thing, I'm going to do a similar flowchart, but this time around is way shorter. So on top, we did for solid liquid mixture. Now I'm going to do for liquid mixture. So for liquid, how do you decide which method to use? You go by whether the liquids, can they mix or not? So if the liquids can mix, which we call it as miscible, because miscible comes from the word mi, mi is mix, they can mix. So if they can mix, then you should use fractional distillation method. But if they cannot mix, that means immiscible. So same thing again, immiscible, mi means mix. Then im means impossible. So it's impossible to mix. Yeah, so that's how you can remember. So it's impossible to mix. So something like oil and water, you know that oil always float on top of water, right? So that we will use separation funnel. Or separating funnel also can. Separating funnel. Then the example is shown here. Yep, so follow and copy this down. Okay, then next is magnetic separation. Yep, so it will be this four. So usually the way I remember, right, that time like my primary school student, they were like telling me, that I find it quite funny. They also giggle. How they remember is they go by ISNC. I see naked chicken, because chicken don't wear clothes. Yeah, so that's why I see naked chicken. Yeah, so it's like iron, steel, nickel, cobalt. That's one way to remember. Okay, then yeah, so need to know the examples over here. Okay, then for chromatography, so chromatography, it would be a separate section already lah. Yep, so chromatography mainly is that there's RF value calculation. Take note that RF must be less than 1. If you calculate until your RF value is more than 1, that means your answer somewhere wrong already. Yep. So it must be less than 1. So in order for it to be less than 1, that means the top number has to be a smaller number, divide by bigger number. So that, in math, small over big, it will be always less than 1. Then your final answer, do you know how many dp or SF to present your answer in? Is 2 dp. Okay, so express in 2 dp. Although normally chemistry, we always do 3 SF, but only RF is special case. You go by 2 dp. Okay, so then for chromatography, need to know that the RF value, what does it represent? So generally is that the greater the RF value, it means that the greater the solubility of the substance. Why? Because when your RF value is bigger, that means the numerator should be bigger number, right? Yeah, that means in this case, the substance travel further. If the substance can travel a lot, that means the substance can dissolve very well. That's why it can travel up together with the liquid. Yep, so that's why this means also that the substance travel further. Can you follow and copy this down? Okay, then next is that for chromatography, there is like ascending and descending method. Ascending is like you must go up. Like example, I ask you to climb up the staircase. You will climb slower than you climb down, right? Because climb down is like very easy. Follow the gravity. Yeah, so downwards will be faster, and then the spots will separate out further also lah. Yeah, that's all. Okay, so let's now try out the questions. So question number 1, can you do it now? Then I'll go through question 2 and 3 with you. Yeah, so do question number 1 now. Sorry, I need to go to the toilet a short while. So meanwhile, can you all do question 1 and 3? 3, I think is manageable because the answer are all very short. I will go through question 2, the long one. Okay, so you do question 1 and 3. Okay, so maybe likewise for those online, once you are done, can you raise hand to let me know for question 1 and 3? So once you are done, remember to click the raise hand button to let me know. If you left with like a few questions that you really don't know how to do, but you have looked through it already, then it's considered done, then you just raise hand then. Let's wait for those online because like majority of them still not done yet. So once half of them is done, then I'll go to the answer. That's question 1 and 3 you'll do. Once you finish question 1 and 3, then click the raise hand button. Okay, so I think I shall start to go through the answer now since for online, like 30 of you have already completed. Okay, so for this question number 1 here, oops, I realized I accidentally showed the answer already. Yep, so maybe can you check your answer now? The answer is B. So just to check, any of you need me to go through question number 1? Need me to explain? Anyone needs? So don't need, okay, then I move on to the next page. Okay, so moving on to the next page over here. Yep. So yeah, you're supposed to do deductions and realize that, oh, this ninhydrine is actually a locating agent. So what does locating agent do? You need to explain, right? So locating agent is to mainly react with colorless substance so that it will become colored or it forms a visible spot. Okay, say form a colored spot also can. But visible will be better because visible means now can see already. For the person whose name is called Zoom user, may I know which question are you referring to? So Joshua is asking, are you supposed? No, you're not supposed to memorize that ninhydrine is a locating agent. Don't need to memorize. So this is actually a deduction. Yeah, because if like normally chromatography, we just do chromatography ma. How come suddenly need to spray something? So most likely is that, yeah, it's because cannot see. That means most likely is that when you spray, usually we spray locating agent. If not, we don't even spray anything. Yeah, so it's like by deduction. Also, okay, so are you all done noting down? Can? Okay, so I shall move on. If you're not done, then you take a screenshot. I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so back to question number 1. By the way, I'll recommend that next time when I ask I need to go through, you immediately let me know so that I don't need to like keep on go back and forth. Okay, so for this question over here, why is it not step number 4? Why is it add water? Is because you have to read the instruction carefully. What are you trying to get? You are trying to get K. So now you must make sure that K is a more unique you must have a more unique property so that you can separate out K from the rest. So best is you do this because can you see among the rest, K is the most unique. Yeah, so that's why you should choose water. So don't need to choose ethanol. Yeah, so that's why it's just you add water in. So after you add water, L and M will end up as the residue. Then K will be the filtrate. Yeah, that's how you can isolate out K. Okay, so moving on to the next part, which is here. Come check your answers. So how, anyone need me to explain B or C? Need to explain? So all okay, can understand? Okay, then in that case, I move on. Okay, so moving on to part D, here are the answers. Can, I'll go through part D. Okay, you check your answers first. Okay, so for part D, how to get the answer of cysteine? So mainly is that you have to refer to the diagram and the table above. Okay, so I screw up. Should be done with part F by now. Anyways, no worries. If you're not done, I'll come back to it again. Okay. So for cysteine, how to get the answer? So mainly is because for cysteine, if you look at the RF value, so they told you that with methanol is like 0.83. Okay, so let me write it down first because I need to scroll to the previous page. So methanol for cysteine is 0.83. Then ethanol is 0.17. So remember, this one is actually the fraction, right? We always take like the distance traveled by your substance divided by distance traveled by the solvent. So this is actually like a fraction of how much the particle traveled. So that means in other words, for methanol, it is actually saying that it actually traveled like about 83%. Then for 0.17 is like it traveled like 17% of the distance. So now if we were to refer, okay, maybe because usually we don't work backwards, usually you work forward like from the question here. So the thing is that for methanol, you ignore this point because this point is saying that there is the presence of like the A2 and A3 and you cannot really tell them apart also because all of them are at the same position. So you choose the more unique one. So this one is like traveled 5 out of 6 cm. So isn't like 5 out of 6 cm kind of like around like 80% like that? So that's why you can choose this cysteine. Then for over here, this one, since the 3 of them same height, so again, you can't like distinguish. So you choose the more unique one. So this one, the more unique one is like 1. So it's like 1 out of 6. So 1 out of 6 is kind of like 17% like that. Yeah, so that's why in the end, these 2 percentage will match closely to cysteine, which is these 2 values here. Yeah, so that's how you get the answer of D. So just to check, Madeline can understand the explanation? So the other parts, all right, right? Need me to explain? So okay, right? Okay, then in that case, then I move on. Okay, so let's move to question number 2 that we have skipped. So I'm moving on already. 3, 2, 1. Okay, moving on. Okay, so for question number 2, which I said that I will be going through. Okay, come, let's do it together. So they said that a chemist would like to obtain copper 2 sulfate crystals from aqueous copper 2 sulfate. So that means in this case, is actually trying to get solid from this aqueous solution, the liquid. Yeah, so then they ask you to describe the steps that the chemists have to take to obtain the copper 2 sulfate crystals from its solution. Okay, so if you from liquid state, you want to become solid state. So in this case, how do you like get rid of all the liquid? So what is the method that you can consider using? So can I have some suggestion? crystallization could be possible, or maybe like evaporation to dryness, because like as long as you need to get rid of the water. But between crystallization or evaporation to dryness, what you do is you check over here, the examples. Yeah, so based on your copy, you check your copy. Under crystallization, we did write down the word copper 2 sulfate, right? So that's why I need to recognize like, what kind of substance is like what kind of method. Yeah, so in this case, when you see copper 2 sulfate, you should choose crystallization. Come, let's write it down. So this is a hint to you that you should do crystallization. Okay, so then next is, need to recall what you have learned before. For crystallization, what do we do? So what's the step? Because you need to describe the step. So whenever, by the way, whenever it's steps, can you try to make it a habit to always label the step number? That means I need to write number 1, do what? Number 2, do what? Okay, so label the step number plus you start the new step on a new line. That means like step 1 is new line. Step 2, you don't continue again. Step 2, you start on a new line. So start new step on a new line. Copy this down. Okay, so then, so since need to label the step, so we write number 1. So what should we do to perform crystallization? It's very obvious. Crystallization, you need to, correct, need to heat. Yeah, then heat until when? Very good. Heat until saturated. Okay, then after you heat already, finally reach saturated solution. Then, what do you do next? Correct, yeah, cool it down. Yep, so allow the hot solution to cool down. Why? Because you want what thing to form? You want crystals to form. Okay, then now that you have the crystal that is inside your solution, then what do you do next? Correct. So next step, you filter to obtain the crystals as, whenever it's filtration, we always have the on top and the below, right? So this time around, what is it called? Correct. Collect as residue. Then after you collect the residue might have some like liquid from like the previous, like the saturated solution. So how do I make sure that my crystal is really like clean? So what do we do next? Wash it, correct. So instead of wash is like, wash clothes. Yeah, so we don't really wash lah. So we actually rinse instead. Yep. So rinse the crystals with like you can use the word ionized water, or you can use like distilled water. Both are acceptable. Okay, then now that you rinse it already, rinse is wet, right? So what do you do next? Correct, you pat dry. Yep. So when you want to dry it, you should dry it using what? Tissue paper? Correct. So dry it between sheets of filter paper. Done. Yeah, so if you understand, like you can like visualize what's going on in your brain, then you see you will be able to like form out the steps. Yeah, so it means like don't need to really like memorize word for word kind. Yeah, you just picture yourself doing the experiment, like, wet, then how? Then now crystals form, but the crystal is stuck inside, then how? Yeah, like that. There is no need to elaborate because over here is just the step, describe. Don't need to explain. Yeah, so unless the question say describe and explain, then you say that it is cold distilled water so that the crystal don't dissolve. The so that crystal don't dissolve, that is explanation. But over here, just describe will do. Don't need to explain. Yeah, so done. That's all. Okay, so I shall move on. Oh, you didn't catch the blank now. Okay, then I fill in the blanks for you. Okay, so over here is allow the hot solution to cool for crystals to form. By the way, can all of you also double check just in case you fill in the blanks wrongly? Yeah, do you all fill in the blanks correctly? Yeah, double check your answers. Okay, so done. Let's move on. Okay, so moving on to the next part here. Just now Madeline was saying to repeat for ethanol. I'm saying that like because this one is like kind of similar, you can't really distinguish. You choose a more unique point. So this is about 1 cm. So based on the fraction over here, yeah, it should be 1 cm, which is a substance, divided by 6 cm, which is the solvent. That's why you should take 1 divided by 6. Then the number you press equal, right, on your calculator is kind of around matching with like 0.17. That's why you should choose 0.17. Because the rest is like they traveled more than half the distance. So the rest, it should be like more than 3 cm. Because 0.5 is at least 3 cm already. Why use 1? If not, you want to use this. You use this, then same as like the rest, then it's like you can't really distinguish it. Yeah, so choose the more unique one to be able to tell. Yeah, because after all, anyways, the question also said that like they don't have A1 and A2. In case you didn't read the question carefully, let's highlight the keyword. P is not A1, A2, or A3. So you don't use the A1 and A2. So you use the other one, which is the more unique one. Okay? Yeah, so choose the more unique one. Not the A1, A2, A3. So this one, unique one. This one also got A2, A3. So don't choose this. You choose the more unique one. Yes. It will be up. The answer key will be provided at the end of the lesson. It won't be uploaded. I'll give it to you. Okay, so moving on to the next chapter, kinetic particle theory. This is an easy topic, right? Yes, a solid, liquid, gas topic. Yep. So this one, please go and memorize it. Okay. The most commonly tested ones are arrangement, movement. Yeah, this is 2. So make sure you don't get confused. Arrangement is how you draw. Movement is like move, like vibrate, slide, move at what speed. Okay, so take note that there's a difference. So things to take note in the drawing is that for solid particles, when you draw, make sure that the solid must touch the bottom, because any solid, like example, my pen here, if I let go, everything will drop. Yeah, so that's why solid will drop. So make sure that you touch the bottom. So I write over here, touch the bottom. Then for solid, can you draw at least 3 rows? That's an ideal criteria. So whenever you draw, try to draw it big. If you draw it big, then wouldn't you draw less? Yep. Then when you draw, you try to draw them around the same size. Try your best. Okay, around the same size. Okay, then next it will, yeah, so that means you draw. Okay, I think my square not big enough, so I can't draw 3 rows. But ideally it should be 3 rows. Okay. Okay, then for liquid it would be that you should be drawing it such that is touching the sides and the bottom. Yeah, because like example, like water bottle, you see, it will touch the sides and the bottom. Yep, so that's why when you draw liquid, remember to draw it a bit irregular. So maybe some of them can like float a bit higher, then some like lower. Yeah, with some gaps in between. Yep, something like that. Yep, so you can see gaps. Then make sure that for liquid particles, because liquid don't float, so make sure that they are all touching each other. Can you see? Because you must imagine, like if there's since Earth got gravity, that's why you see the particles are all like touching each other. Yep, so that's why it should be touching. Then with some gaps. Okay, so this is for liquid particle. Yes, it's a must to touch the sides for the liquid. For solid is okay, because solid is like they can stay at whatever position that they are at. So for solid, if you never touch the side, still okay. But solid must touch the bottom. So let me write down. Touch bottom and sides. Okay, then next for gas. Gas, because they mentioned it's far apart, that's how you draw. So if it's far apart, can you at least have one particle that touch the side of the wall? Okay, so at least one touch the wall. Yeah, because if you want to be far, try your best to be far. But don't need all touch the wall. Okay, just maybe at least one touch the wall will do. Okay, if there is a question that asks you solid, liquid, gas at the same time, which rarely happens, you should keep the particle size to be around the same. Yeah, but usually they only ask you one. So that's why if only solid, then within the solid, make sure the circles are all same size and make sure that you don't draw Olympic. The circles shouldn't be like overlapping. Okay, so no overlapping. And then in science drawing, no brushy lines. You cannot draw like that. Wow, I want to get my perfect circle, then brushy lines. Cannot. Okay, so draw with a smooth line. Yeah. Okay, then next is that the forces of attraction for solid, because they are so close together, that means it is very strongly attracted, right? Because so strongly attracted, they are stuck together. But for gas, very far apart. That means very weak attraction. They don't even attract to each other. That's why they are far apart. Okay, then for Tessa, you're asking, can the same element be of all 3 states? Yeah, it's possible. A substance you can boil, freeze, melt. Yeah, got boiling point, melting point. Yep, so it's possible to have 3 different states at 3 different temperatures. Okay, then next is energy. I think you can tell that for the gas is like, wow, move at super high speed. That means a lot of energy. Solid only vibrate about fixed position. You can feel like not much energy. And then density, I think common sense. Okay, so moving on. Should be done copying by now, right? If you're not done, you take a screenshot. I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. So next part over here is about the rate of diffusion, which I think you should know. Factors affecting diffusion would be mass. Yep, because the heavier it is, like example, like you have skinny man and fat man. Fat man got more fats to carry, so by right he should run slower. Okay, but that's my generalization, assuming that both are not athletic. Then temperature. Higher temperature, you will be able to diffuse faster because higher temperature means more kinetic energy. They will move faster. Okay, then next is we need to know this kind of common setup called the porous pod. Porous pod mainly, as the name suggests, got pores. So this one a bit different from like your partially permeable membrane. For partially permeable membrane, it is like only the small one can go through. The big one cannot pass through. But porous pod, big and small, all can pass through. It's just that the smaller one can pass through faster. The big one can also pass through, just that it pass through slower. So all can pass through. Okay, so yep. So for this question, can you give it a try now? Then once you are done, I'll go through the answer. Do this question now. Question 1. So how to tell if the gas is big or small? You check periodic table for the mass. Because generally, if the mass is heavier, like if my mass is heavier, that means I'm fatter, then I'm bigger size, right? If my mass is smaller, means I'm skinny, skinny means I'm smaller size. So David, yes. Yeah, so if it's heavier also move through slower. Yep. So can use either smaller or lighter. Yeah, of course, based on rate of diffusion, when it's lighter, you can diffuse faster. Heavier, it will diffuse slower. Over here, I'm talking about the gas. Yeah, so if the gas is lighter mass and smaller, or the gas is heavier or bigger size, then it should diffuse slower. Okay, so for those online, once you are done with question number 1, can you click the raise hand button to let me know? So seems like those in class also done. Okay, then in that case, I shall review the answer soon. Those online, are you done? If done, raise hand. I realize those physically here, you are much faster than those online. Okay, so I shall review the answer. The answer is, for those present here, what are your answers? What they are right? Correct, A. Yep, the answer is A. So how do you all need me to go through? Anyone need me to go through? Can you tell me now? If not, I move on already. I count down 1, 3, or need to go through. Okay, can. Okay, so over here, you check the mass number. So you just check the periodic table. Hydrogen, the mass is 2. Okay, so now all the numbers I write down here is all the mass. So then NH3 is like 17. This one is like what, 30-ish. I can't remember 30 how much. 34, is it? Oh, 44. Oh, okay, I remember wrongly. And this is like 28. This one is 17. This is 32. Neon is how much? 20, is it? Okay, so then based on this, because they said that they want the upward movement of U. So that means here go up. That means overall you want the left side to go down. That means you want the gas to go in. That means Y should go in fast. That means Y it should be lighter or so-called like smaller size. So that's why you choose the smaller numbers. So smaller numbers are like the more smaller number like these two. Okay, or maybe or in other words, maybe let's compare it this way. X should be heavier than Y. So now let's check. Is X heavier than Y? Nope. Wait, did I see wrongly? X. Again, sorry? Upward. Sorry, thanks for highlighting for me. Oh no, I careless. Oops. Thank you. Oh yeah, I don't know what am I looking at. Sorry. Upward movement of L. Oh no, is this side go up? Why did I write up on the other side? Alamak. Okay, so if you want up, right, that means overall you want the gas to go up. So if you want gas to go up, that means X should move faster. So that means X should be lighter so that X can move faster and get out. Then Y, it should move in very slowly. Yeah, because you don't want the liquid level to go down, right? You want the liquid level to go up. That means don't come in so fast. You go out faster. So if to go up faster means, yep, the Y, it should be heavier. So now let's check. Lighter, right? So this is correct. Not lighter. This one, not lighter. Not lighter. Wait, this is lighter. But this one a bit too close. Like correct, but a bit too close. So it will be quite slow. So A will be a better answer than D. That's why the answer is A. Okay, so moving on to the next question here. This question is quite straightforward. So can you all do it now? Oh, I realized the answer. Is it still in your worksheet? I think they forgot to delete the answer. Let me see. Is it still there? Never mind. Then likewise, for those online, once you have finished this question, can you raise hand to let me know? Reminder again, once you are done, click the raise hand button to let me know.
Y'all can tell y'all are stronger.
while waiting for the rest to be done, just to let those online know that for this chemistry revision kit, if you have collected previously when they were distributing out as flyers at the various MRT station, that's good. But if you would like a copy of this revision kit, where it actually has like notes of like all chapters, yep. So yeah, I can show it to you. Just the contents page. Yep, so if you would like to get a copy of this, you can actually head down to any of our centers, yep, at the Bukit Timah branch, Serangoon branch, or Marine Parade, yeah, to collect a hard copy. So for this revision kit, we won't be able to give you soft copy, yeah, but you can collect the hard copy. And when you come and collect, you can collect all subjects. Yeah, so you can collect what English, math, sciences, all of them. Yeah, you are allowed to collect. You can even collect for your friends, your cousins also. Yeah. Madeline, I'm stationed at Bukit Timah outlet. Yeah. So if you are like interested to like sign up for tuition at like the Serangoon branch, we will I'll later announce more also, like we will actually have like free trial lessons. So you can actually try out like the Serangoon teacher's teaching style and see whether like you like his vibe or not. Yeah. Okay, so since majority of you have finished, so let's go through the answer now. Let me show the answer. Okay, so yeah, just now I was saying like, oops, the answer they forgot to delete it. Do you realize it's like inside your worksheet? Yeah, so that's actually the triple point, which is where the three of them all meet at the same place. Because solid, liquid, gas all meet at this point. So it's just like, just follow instruction, then you should be able to answer it. Okay, then next part, you check your answers. I think should be okay. So take note that because this one is a change. So change, you must tell me like what's the original, then final. Then original, final. That's why it must be from something to something. So then make sure you just copy correctly will do. So in this case, it is a change from solid to gas. That we call sublimation. So just copy the solid and the gas. By right, if you copy it, should be correct, I think. Okay, so I shall move on. I take it that you all can copy correctly. So if you still need to do the correction, can you take a screenshot right now? I'm moving on in 3 seconds. 3, 2, 1. Okay, I move on. Okay, so anyways, no worries. I'll give you the answer key also. Yeah. Okay, so then the next part over here is on atomic structure. So for atomic structure, need to know that total there are 3 subatomic particles: proton, neutron, electron. Need to know that all of them they have like another name for it. Okay, so for like proton, the other name for them it is called what number? Like if you say proton number is also known as what number? Atomic number. Yep. So why is it called atomic number? I think your teacher have never told you before. Because atomic number, right, is actually the atom's IC number. Like, you know, human, we also got IC number, right? So if it's my IC number, means confirm is me. So no matter I go and do what plastic surgery, I gain weight, lose weight, or even want to do transgender surgery or what. But no, I'm legit a female. Okay, so then yeah, so if you were to do whatever surgery, my IC number is still the same, right? Can never ever change. Even I change my name, my IC number still the same. So same for atom also. Atom IC number can never ever change. So once you see the number like maybe 6, right, confirm it is carbon, cannot be anyone else. Okay, so take note that proton number is a number so unique to them that that's why atom cannot gain or lose protons. Atom can only gain lose neutron or electron only. So when you gain lose neutron, then that will be isotope, because it's mentioned here that isotope have different number of neutrons. And then when you gain lose electron, that will be ions. There, over here, gain or lose electrons, you will form the respective ions. Okay, so take note, only N and E can gain or lose. P cannot gain or lose at all. And P number won't change. Okay, then next is for proton, P for proton, P for positive. That's why it's positive charge. And take note, in exam, right? Take note, in exam, you cannot write as plus. Like if they ask you, what is the charge? You just say positive or plus. Cannot. In exam, you must write in the number 1. And take note, it must be +1, not 1 plus. So in this topic, where you put the charge and the number, it matters. So when do you write +1? When do you write 1 minus? So it will be based on this. If they ask you the charge, they really say, I want the charge. The focus is the charge. So you should write the charge first. Okay, so that's why you write plus first, minus first, the one later, but still need to include. Okay, or maybe, for example, if I ask you, what is the charge of maybe so maybe not sodium, maybe chlorine ion, or maybe chloride. Okay, let me write properly. Chloride ion. So what is the charge of chloride ion? The answer is, must write the charge first, minus. But remember to include the number 1. Okay, so I shall just write down a note over here. So whenever they ask you for charge, you must always write down the sign first. You write down the charge, then the number. Whenever they ask you for charge. Okay, as compared to, I think you know that there's like chemical. Hello, please do not abuse, please. This is a free lesson. If you don't want to attend a lesson, you leave the class. It's not funny. Okay, so then over here, let's continue on. So in this case, for the, hold on. Okay, so right, in this case, for the let's see. Yeah, so for the charge, you write charge first. But sometimes they might ask you like chemical formula. So if they ask you for chemical formula, okay, so for the chemical formula, right, is that like for example, if I ask you what's the chemical formula of chloride ion? Yep, so in this case, it will be, yep, so if I ask you formula, then take note that when you write, right, do you realize the minus sign is, sorry, the number 1 is gone. Yep, so that's why when you write chemical formula, you do not write the number 1. So this time around, it will be actually, if have number, you number first. But then if got number 1, you should omit the number 1. So omit 1, or you write the number first. For example, like if I ask you maybe chemical formula again, but this time around chemical formula of maybe aluminium ion. Yep, so if it's aluminium ion, when you write Al3+. Yep, so in this case, is that as mentioned, when you want to write, you write the number first. You write the number 3 first. Okay, so don't write the charge first. So that's why, like, how do you decide when to write like charge first, when to write number first? Is it 3+ or +3? You follow the instruction. They say charge, you write charge first. If not, you write number first. So same for drawing also. Like for example, if it's Al, then like you need to like, you know, like draw the like electron and stuff. Then after that, you like, you know, need to write the square bracket, remember, like the drawing. So this kind, you also write 3+. You write the number first. So it's only charge, you then write charge first. The rest is always number first. If you swap it around, your teacher will mark you down, okay? So make sure that when you draw or formula, it's 3+, not +3. Okay, then moving on. Okay, so then next is, yeah, then continue on with the charges. So for neutron is like, come from the word neutral, right? So that's why for neutron, the charge is neutral. So neutral, it will be 0. Then electron, since one is plus, one is 0, the other one, it will be minus. Kara, maybe you stay back after class, then I send you a copy. Okay, then next is for the mass. So take note that only proton and neutron got significant mass. Electron, the mass is like almost like 0. Yep. So that's why for electron, you can take it as negligible mass. That's why we would say that how heavy is an atom? An atom is depend on how many proton and neutron you have. That's why for proton and neutron, it will give you the mass number also. So that's why wait, do I have some space to write? Not sure. Okay, a bit no space really. So this one is also known as the mass number. Yeah, if you calculate total how many P plus N, that is the mass number. Yeah, and that the mass number is also known as the nucleon number. So nucleon come from the word nucleus. Yeah, that means nucleus got how many? So nucleon is nucleus. Take note of the difference between nucleon versus neutron. Neutron number and nucleon number are different things. Because if you look at the word nucleon, nucleon is P plus N. I write down over here, P plus N for nucleon. But then for neutron, it will be just N only. Okay, so take note of the difference. Nucleon is like nucleus number. Okay, then what else? I think yeah, generally that's about it. Okay, so then moving on. Okay, so then yep, so now that we have atom, but usually atom don't like to remain as atom because their shell is not full. Something like for us, like when we fill our water bottle, like maybe you fill it to school or what, usually we fill to full, right? We won't feel like halfway. Yeah, so same for atoms, they always like it to be full. So in order for it to be full, that means you have to lose the electron to make it a full shell. So when you lose electron, take note, I mentioned just now, you cannot gain or lose proton. So when you lose electron means you less negative. Less negative means more positive. That's why it's cation ion cause of the plus sign. Cat is plus. Then when you gain negative electron, it becomes anion. Yep, this is negatively charged ion. Then lastly, it will be isotopes. Isotope is where you change the number of neutrons, but the proton is still the same number. So need to know that between ions versus isotope, you need to know that for ion, that means you compare the atom versus ion, they will have different chemical properties. As compared to isotope, isotope will be different physical properties. So take note, okay, that ion is chemical properties that is different. Isotope, it is physical properties that is different. So that means for ion, the physical property is the same. So write down over here, same physical properties. So what is physical property? What's chemical properties? Okay, so for physical properties, physical refers to like physical feature, like my physical build. Maybe I very slim. That means my mass is small. So that's why physical means like mass and anything you learn in physics. Like maybe all of you learn like at least lower side physics, right? So like mass, electrical conductivity, density, heat conductivity. So these are physical. Then for chemical properties, chemical refers to chemical reaction. So what decides whether is a substance like reactive in a chemical reaction or not? So this actually depends on electron. Yeah. So for electron is that if like you have, okay, so like for example, like the atom, like they gain or lose electron. So when you lose electron, this is happening only in a chemical reaction. Yep. So that's why there is a change in chemical properties, of course, your electron number changed. But then for isotope, the electron number is still the same, right? You only change the neutron. So since same number of electron means same chemical property. For my annotation, it is all these pink color ones are all for the ions. Isotope, I haven't annotate anything at all. So all this all for. So I label like that. Yeah. Okay, so then for isotope, is a change in physical properties. Why? Because when you change the number of neutrons, neutron affect the mass, right? And then your physical build, if you gain mass, means your physical build became bigger size. Yeah, that's why change in physical properties. This is one of the common things that school usually like to ask about, like chemical properties, physical properties. So make sure that you know how to distinguish it. Yeah. Okay, then I think that's all. Yeah. Okay, so now can you give it a try to do the question number 1 till 3A? Yep, so do question 1 to 3A now. I'll go through 3B and 3C, the longer sentence writing time. Yeah, so you try the easier ones, I'll do the difficult ones with you. Hmm. Hmm. After you are done with question 1 to 3A, of course, you can go ahead to challenge yourself to see whether you can do B or C. But if you just want to wait for me to go through, sure, also no problem. Yeah, so once you finish 3A, at least you raise hand first. Then I can go through the answer.
Can I put bottle of water?
You don't have the goodie bag, is it? Oh, okay. Have you received the goodie bag before so far? From OVERMUGGED? Haven't received. Oh, okay, then I give you one. I think there was some more late. Who came in late? I don't remember. Any of you haven't received the goodie bag so far? Oh, you haven't received the goodie bag so far. There's water and let's put everything inside the water and draw. Once you're finished until 3A, click the raise hand button, then you can continue to attempt B and C. Yeah, I believe all of you should have at least completed the MCQ by now. So I shall review the answer. The answer is D and A. So how any of the questions that y'all would like me to go through? Any question to go through? So all okay, right? Okay, question 1, sure. Okay, so for question number 1, they're asking you which ion has the correct quantity. So for maybe I go through D first. For Joshua, since you got it wrong, maybe you let me know which option you got it wrong, then I explain that option for you. Okay, so for this one over here is that, remember, I told you proton number is the atom IC number. IC number can never ever change, right? So that's why if the number here, take note, in periodic table, I know the number is like flipped around. You take a look at periodic table, oxygen is 8 on top, 16 below. But here is inverse because this way of writing, this is called the nuclide notation. Yep. So for nuclide notation is that they will flip the number and they put it on the left instead. So can you see it's not like directly above and below O, it's on its left side. So this is actually nuclide notation. So in this case, what you do is that the top number is the number of proton. So the number of proton, it will be 8. Then number of neutrons is actually the difference because the below, just now we mentioned this is the mass number. Mass is how heavy is due to proton and neutron. That's why to find the neutron, you take top minus bottom. So top minus bottom, you can cancel off the P, left with the N. That's why if you take 16 minus 8, the 8, it will be the number of neutrons. Then for electrons, as long as it is an ion means it has full shell, right? So if you have full shell, full valence electron, that means the number can only be first shell full, which is 2, or first and second shell full, which is 2 plus 8, 10. Or else it's first, second, third shell all full. 2 plus 8 plus 8. That will be 18. So that means for ions, right, all of them here, you can only choose 2, 10, or 18. So that means only B or D is possible. Yep, so that's why in this case, D is the correct answer. So then for this one over here, neutron is not the mass number. It is nucleon that is the mass number. Okay, so that's why this number here is wrong. It should be just top minus bottom. So it should be 10, not 19. Yep, so that's why answer is D. Okay, then for question number 2 over here, which statement explain why isotopes of the same element have the same chemical properties? Remember just now I told you in my annotations, we have written down, you have copied down, right? That chemical properties depend on number of electrons. That electron. Okay, it depends on number of electrons. Yeah, so it's just the notes that I've written for you just now. Okay, then moving on to question number 3A. Let me give you the answer. So this one, it would be 2, 8, 8. You follow your school, but if your school say choose to write comma, then you write comma. If your school say full stop, you put full stop. Then this one, it will be non-metal. Then below is metal. So how anyone need me to go through any of these 4 answers here? So all okay, right? Okay, then I shall move on. Okay, so moving on to part B, let's do it together. For those of you who have attempted, you just check whether if your answer is correct or not. Okay, so they said that from the table in part A, the chemical symbol of 40P don't have charge. But then for this one, there is a charge of, oh, actually this one, the school write a bit not correct. Whenever it's charged, you should write as +2 instead. Because if they ask you for the charge, the emphasis is the charge. Can you modify it? Hello, can you edit the question? Okay, then next, with reference to the subatomic particles present in this and this, explain why this is so. Okay, so need to explain like why one charge and one no charge. In terms of subatomic particles, what is subatomic particles? You look at the notes, this chapter, at the start, the table got the word subatomic particles, right? So you must recognize it. Like question asks you this, then you must know what are they trying to signal you for. So yep, Madeline is correct. There's proton. What else? Still have, right? A neutron and also electron. So whenever they say subatomic particle is this 3, because atom is the big one. Sub-level means sub-level of the atom. That's why it's called subatomic particle. So it's sub-level of the atom. So sub-level, it will be what makes up atom, which is the proton, neutron, electron. Okay, so then in this case, yeah, must explain like each of them got how many like proton, neutron, electron. So in this case, should we write down like how many of each of them are? Like, do we need to cover all 3? Or maybe can we just maybe pick out just a few? So maybe if you talk about like 40P, do I need to tell them how many P, how many N, how many E? Need to mention all 3? Don't need, right? So which 2 should we mention? Proton and electron will do. So these 2 will help us determine the charge. Because proton is P for proton, P for positive, E is negative. Yep, so let's now identify the number of P and E in each of them. So we start off from the first one. So for the first one is the 40P. For the 40P, in this case, if we were to, wait, just to check, for your worksheet, is there any more number below here? Don't have, okay, can. Okay, so actually, I think the number is missing, but it's okay, we can still write it in. So remember, I told you for nuclide notation, they usually write the number on the left side. Okay, so then you must write both. So what should the bottom number be? Can you refer to the top for P? What number should I write at the bottom here? Remember, the number will get swapped. Yeah, so the bottom number, it should be the number of proton, right? And then can you check for P, how many proton are there? Correct. So that's why you write 18. So it should be 40, 18P. So for this is an atom where then you fill in the blanks. So you go and identify. Since we said need to identify the number of protons, so you identify. So how many protons are there? And proton, what's the charge? Madeline, we compare P and E is because only P and E got charge. So that will affect the charge because the question is about the charge. Neutron don't have charge. Neutron is neutral. So no charge, then don't need to care about that. Okay, so maybe can I go round to ask you all for the answer for the blank? So maybe can I start from you first? Can you tell me what is the number of protons? Correct. Then can you tell me what's the next blank? Very good. Positively charged. Then maybe can I get your answer? Okay, speak a bit louder. I cannot hear. Neutralized by? No, electron is below. Or maybe can your friend help? Not sure. So anyone knows what is this blank? Equal, because only when the proton is equal to the electron, that's why they will be no charge, right? That's why you see over here, don't have charge. Yeah. And then maybe can you all continue to help me fill in this blank? This blank, positive or negatively charged electron? Correct. Electrons are negatively charged. Yep, so these are the answers. Good. So for those online, please check and see if your answers are correct. Okay, then done for the first one. Haven't moved on to the second one. Okay, now let's do the second one, this one. Okay, so same thing again. Let's write down the number again. On top is the mass number. Below should be the proton number. So what's the proton number? Correct, it's 12. Okay, so then in this case, yep, so now we write down. So this time round, let's write the same style. Instead of is an atom, this time right is an what thing? You fill in a blank on your own bar. Okay, so maybe this time around I start from the back of the classroom. So the girls at the back, maybe can you all tell me what's the answer for the first blank here? Each person one blank. So who want to say first? So what's the first blank? So just now it's an atom. So now this one is, can you say louder? Yeah, correct. Okay, since you said already, then now your friend has to say. So now it's how many more proton than electron? Do you count how many more? No, it's not 12 more. So when it is an ion, right? Ion, okay, that means you're comparing R as an atom. That means you're comparing R versus R2 plus. So it will be a difference of how many like electrons and protons? Joshua, the second one. So how? No idea. If no idea, then later I come back to you again. Okay, so maybe the next row, then can I have the answer for this? Correct, 2. Because if you 2 plus, that means you lose 2 electrons, right? If you lose 2 electrons, means that now I come back to you again. So then the girls at the last row, so what is this? Proton is positively charged. Then now, wait, no, now your turn. Yeah, so what's this blank? Yeah, correct, negatively charged electron. That's why now the first row, so either of you. Very good, +2. Remember I told you when the sentence says that it's charged, you write down the charge first, okay? Yep, done. So this would be the answer. Oh, you want to write cation also can. Can, either ion or cation. So Madeline is asking for chemical formula charge. Okay, chemical formula is chemical formula. Charge is charge. Chemical formula means like that. or 2 plus. This kind, you write number first. But then when they ask you for charge, you write charge first. So that means only charge, you write charge first. The rest, all number first. Then anyways, Madeline, proton P for proton, P for positive. If you have more proton, you are more positive, not negative. Okay, then I shall move on. Part C, state and explain the chemical reactivity of P. So in this case, can you look at, on top, is P reactive or unreactive? Is P reactive or unreactive? Those online you can participate too. Unreactive. Do you know that there's actually another word called unreactive? Start from letter I. Inert, correct. Yeah. Actually, inert would be a better word. Yeah. But unreactive still acceptable. Okay, so then next, why do you all choose P? How do you all know that P, why do you all choose P? I mean, how do you all choose inert? Like, why do you know that it's unreactive? Why? Correct, it's stable. But what makes it, what can you see such that you know that it's stable? Correct, it has a full valence electron shell. Yeah, so let's write it down. It has a fully filled Yep, so in this case, that means since it's really full, like my water bottle is full, then I don't need to like pour any more water, right? So don't need to gain, and then shouldn't lose because it's full already. Yep, or share electrons. Why include gain, lose, share, right? It's because gain and lose is ionic bonding. Share is covalent bonding. Yeah. Electrons to achieve. Oh no, I don't have space. Okay, I write on the left side. Okay, sorry, I'm going to squeeze on the left. Yep, to achieve there's this very common way of saying that I think you should have written down before in school. Do you all know what is this? To achieve a stable, correct? Very good. Stable electronic configuration. So this one is actually also one of the answering technique. So try to remember that whenever it's atomic structure topic, can you try to remember to use this phrase whenever you are trying to say something has full shell? Okay, this is a very important keyword. Okay, so after you are done copying, can you highlight this? Must have this keyword. Okay, this is very important. Okay, then yep, so let's continue to fill in the blanks. So can those this time round, since the students present here physically, they fill in the top. So now can I get those online to tell me what's the answer for this blank? So can you type it in the chat? Then I'll write it in for you. So what is this blank over here? It has a fully filled, correct, valence, electron, shell. Thank you very much. Yep. So then he won't gain or lose. That's why I can achieve this configuration. Okay, so I shall move on. I take it that you all should be done copying. Okay, so done, right? I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, then the next part, the different bondings. Yep, so need to know that there are 3 types of bonding. Ionic bonding happens when it's metal plus non-metal. Covalent bonding happens for non-metal and non-metal. Metallic bonding is just metal law, the name already says so. Okay, then next, you need to know what they exist as. So for ionic bonding is that because of the word ions, that means they will all exist as ions. So that means in covalent bonding, don't have ions, Yeah, so take note that ionic bonding has ion because of the name that ion. That's why it's ionic bonding. Then how about covalent bonding? If they don't exist as ion, what do they exist as? They exist as molecules for the simple molecular structure. So that means all non-metal and non-metal will be molecules except diamond, sand, and graphite. Okay, so take note, they exist as molecules. By the way, what's discrete? Discrete just means simple. Yeah, because usually when you draw, it's like what? CO2, very simple, you just draw 3 circles. Or like H2O, also like 3 circles, very simple to draw. Okay, then yep, so for covalent bonding, be careful that you can subdivide into 2 of them. You can subdivide into simple molecular or giant covalent. Okay, then next is metallic is just metals. Yeah. Okay, then next thing to take note is the definition. What are the things that are attracting? So for ionic bonding, as they already say, is ions. Ion means got cation, anion attract each other. So it's the attraction between the cation and anion. For covalent bonding, because don't have ion, so what is attracting? So it will be the nucleus, because the nucleus has proton and neutron, right? And proton is positive. So positive and negative will attract. Yeah, then for neutron is neutral. So neutral means like they won't get attracted. So yeah, don't need to involve neutron. So it's mainly the proton and electrons that are attracting. Then for the metallic bonding, what are attracting? Yeah, so it will be the metal cation, which is the fixed metal cation. Can you add in the word fixed? Because the cation don't move. The fixed metal cation and the C of delocalized electron. Delocalized means they can move. So the attraction is the cation and the electrons that is attracting. Okay, then next, need to know whether are the attraction strong or weak. So for ionic bonding, it is strong. Covalent bond actually is very strong. But every time you remember that your teacher say what low amount of energy required to overcome, then low boiling melting point. Why? It's because for covalent bonding, between the covalent molecules, like maybe we talk about water, which is H2O. Yeah, so if you talk about this bond here, this line here, this covalent bond is very strong. Okay, so this line here, let me just indicate. This line here, this is the covalent bond. The covalent bond is strong. It is the another bond, which is the intermolecular force of attraction that is weak. I write shortcut, intermolecular forces of attraction that is weak. What is intermolecular force of attraction? So that means, example, I got another water over here. Then the bonding between one water to another water, this is the intermolecular force of attraction. Something like, sports day, you got inter-house competition, right? Inter-house is between different house compete. So inter-house means different house compete. Intermolecular means different molecules then attract. Then one molecule, another molecule attract. This intermolecular force of attraction. So this one is weak. Then for metallic bonding is also very strong. That means, in other words, all bonds are strong except intermolecular force of attraction. Okay, then next part, it would be need to know the different properties. Yep, so I shall scroll down. If you are not done annotating, can you take a screenshot? I move on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so for the property over here, so need to know that the boiling point, melting point, they are all high except the simple molecular, because since you know that the covalent bond here is so strong, it's so strong that it's impossible to break. That's why break the easier one, break the weaker one. So since it's so weak, I just need a bit of heat, I can break it already. That's why the boiling point, melting point is very low, because you just need a bit of energy, you can overcome the weak intermolecular force of attraction already. Yep, then the rest are all high. And then the attraction I already went through with you just now is who and who attracting, so should be no problem. Next is solubility. So need to know that for the giant metallic, that means metallic bonding and giant covalent bonding, they cannot dissolve in any liquid at all. But then for ionic, they can dissolve in water. Because for example, salt, you know that the salt that we use for cooking and eating, this is ionic, right? Because it's metal plus non-metal. So this is ionic. Ionic is metal plus non-metal. So salt can dissolve in water. That means the other one cannot. What is organic solvent? Organic solvent, don't need to know now, because there will be this chapter called organic chemistry at the end of Sec 4. Yeah, so organic just means that it has many C, H, and O atoms. So water don't have C. That means water is not organic. So take note that for this for chemistry, whenever we talk about organic or inorganic, it doesn't mean like the supermarket, you know what the healthier food section or not organic vegetable versus like what inorganic. No, it's different thing. Chemistry, the organic and inorganic is not fresh or not fresh. It's about the like whether is there like CHO atom or not. Yeah, so water is considered inorganic solvent. Then for simple molecular, it will be opposite. Yeah, so for simple molecular, it will be soluble in organic. How to remember? Like after a while, you scared, ionic and the simple covalent, you scared you memorize the other way around. So you go by, because simple molecular are non-metal. CHO, all these are like the non-metal kind. So carbon confirm non-metal. So non-metal is like organic. So usually like same, they can dissolve. Yep. Then for water cannot, because water should dissolve the salt instead. So that's the way to remember. Or you can just remember salt soluble in water, then the rest will just be opposite lah. Yeah, like that. For graphite, it should be high boiling melting point also, because giant covalent. Okay, then yeah, that's all. So moving down. So next part is whether do they conduct electricity. So this one I think quite straightforward. Your school teacher should have explained to you, so should be no problem. Okay, then done for the recap. Okay, so for the questions behind here, yep. So can you all wait? Let me see. Because of time constraints. Let me see. Okay, maybe we do the open-ended question. The MCQ, I let you try on your own, then you can check with the answer key for the answers. Okay, so let's move on. Okay, so for the drawing, this one, I let you try on your own also. Yeah, should be all right. So mainly first is you first need to decide, is it ionic bonding or is it covalent bonding? Then you then know how to draw it. Okay, so this one I leave it to you to try out. We do the more difficult one, like 3 marks, then long sentence writing kind. Okay, so for part B, they said that explain in terms of bonding and structure why aluminium fluoride has a high melting point while phosphorus trifluoride has a low melting point. Take note, one very important thing. Some students, they memorize everything. They write everything in, everything correct, right? Then when they take back their paper, then they shock, 0 marks. Why? Even though they memorize everything correctly. Because whenever they ask you to, like, you see this kind, compare. Whenever it is comparison question, right? You cannot write down one whole paragraph aluminium fluoride, then one whole paragraph on phosphorus trifluoride. Cannot. Because when they ask you compare, you should compare point by point. So what do I mean by that? So usually for the point by point, the first point, it would be that you should mention about like the structure, because they mentioned that mention about the bonding and structure. So maybe your first point, you can talk about like the structure. Then second point, you can talk about the bonding. So maybe you can talk about the bonding, is it like strong or weak? Yeah. Then for the third point, they tell me the amount of heat to overcome. Then the last point, you tell me that conclude. So what happened to the melting point? So that means how you structure your answer, right? It should be that aluminium fluoride structure and then phosphorus trifluoride structure, full stop. Then second sentence, it will be the strength and what kind of bonding is in aluminium fluoride and the strength of bonding in phosphorus trifluoride, full stop. Then you move on to the next one. So same thing. So that means what you need to do is your sentence should not be substance, then next substance. Cannot. It should be point by point. Clear? Yeah, so that's why you cannot write one whole paragraph of aluminium fluoride, then one whole paragraph on phosphorus trifluoride. That's 0 marks. Yeah, because teacher will say that you didn't show comparison. You just like regurgitate from your memorization. This is very important because I do see students that get 0 marks when they very quiet, they really like study hard. They write down everything that they memorize, but 0 marks. Okay, so be careful. So this is something that you need to take. Okay, so then yep, so this one I'll leave it to you to, okay, I think we do together so that maybe you can better understand. Okay, so now we do for the first one for aluminium fluoride. So for aluminium fluoride, can you all check the notes? What kind of structure does it have? So aluminium fluoride is metal plus non-metal, right? So if it's metal plus non-metal, what kind of bonding is this? Correct, ionic. So then you check the notes in front. For ionic bonding is what kind of structure? Fill in the blank. You check the front page of the notes. Then remember I told you don't write everything on aluminium first. You compare immediately with the next one. Phosphorus trifluoride. Then you write down what kind of structure? Yep, so for phosphorus trifluoride, how to know what structure it is? So you check. This is phosphorus and fluorine. Both are non-metal, right? So if it's non-metal plus non-metal, what kind of bonding is this? So can someone let me know? What kind of bonding is it? Covalent. Yep, then you check the covalent. Is this the giant covalent? No, right? Giant covalent only got 3. Got diamond, sand, and graphite. So this is not sand, graphite, diamond. So it's the simple covalent. Then you check what kind of structure is it? Okay, so done for point number 1. Then we move on to point number 2 about the strength and what kind of bonding it is. So for aluminium fluoride, Everything just keep referring to the notes in front. So yeah, as you can see over here, I also mentioned that ionic bonding, you use the word ions. Then for covalent bonding, you use the word molecules. Mandolin, usually we don't compare the covalent bonds because it's too strong. It's strong until like you cannot break already. So just look at the intermolecular force of attraction. And for those of you who are fast, meanwhile waiting for the rest to be done, why not you do the MCQ in front? Yeah, since I'll be giving you the answer key. Okay, so for those online, once you are done writing the answer for part B, can you click the raise hand button to let me know? Oh yeah, true. I actually should link back to the, oh yeah, I missed out the last sentence. Oh yeah, then actually should write a conclusion. Hence, who has higher and lower melting point? Yeah, thanks, Zafira, for the reminder. Yeah, so hence, aluminium, can you add it in? It's a high melting point. Wow. Oops, no space. Okay, so due to time constraint, I think I will just review the answer now. So for those online, if you are not done, then I think you just copy down the answer. Okay, so I shall review the answer now. So this part here is giant ionic lattice structure, which you can find from the notes in front. And then for covalent, it's always simple molecular structure. Then this one is strong. Yeah, so for those of you who are done already, can you double check your answers and see whether you fill in the blanks correctly? Just in case, right, you didn't fill in correctly. Yep, double check your answer, please. Make sure you fill in correctly. Yep, so this will be the answer. So for the 3 marks, it will be a 0.123 because number 4, they already tell you that which one high, which one low. It's just like, like to, how to say, make the answer more complete. So the last sentence, if you don't have it, it's still okay because the question have it already. So you are marked based on the first 3 points for the 3 marks. Talking about the more, actually, Wait, oh shucks, I missed out. Oh yeah, I missed out the point number 3. Alamak, sorry, it looks very long already. Then I thought I finished that. Oh no. Oh, sorry. Can you add in about the heat? Yep. So this time around, since the comparison, you can just say that more heat is required to overcome the stronger forces of attraction in aluminium fluoride than the other one. Thanks, Zafira, for the reminder. Oops, I missed out. Yeah, so can you add it in? Yeah, my point number 3 missing. Okay, so anyways, since it's also 1 p.m. already, I don't want to hold you all back further, but I will continue to teach finish because only left 3 pages lah. So up to you. If you have something on, then you need to leave, you can leave now. But if you don't have anything on, if you can stay for a while, then I'll just continue to finish up the last 3 pages. Yeah, so if you need to leave, you can leave now. Okay, so I think I shall move on. So if you are not done, maybe you take a screenshot. So I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so moving on to the next page over here. So this one is on the about further go deep into the different type of bonding as well as like focus on like the metals. Yep, so over here is like alloys. So take note that this one is actually an answering technique. Okay, so this one please go and memorize it. This question very, very, very commonly tested. Okay, so this one need to know. Okay, so this one please go and like memorize. Yep, so like for alloys is where you mix different material metal. Like maybe I want to get rose gold. Rose gold is where you mix gold and copper together. Yep, so what happens is that when you mix different metals, they will have different atom size. Then it will disrupt the orderly arrangement. So this one not only need to know how to write, need to know how to draw also. So when you draw, you just make sure that when you draw some are small. Then suddenly there's like big one to disrupt the arrangement. Then like suddenly got a big one, something like that. Yep, so this is how you draw it. So just draw like big and small, you mix it. Okay, yep, like that. Okay, so this will be how you draw for alloys. Okay, must mix big and small. Okay, then next is that because the orderly arrangement is disrupted, then they cannot slide off. That's why it's very strong and hard. Then next is for the structure, need to know like how they are bonded. So diamond is always a tetrahedral structure or the 3-dimensional structure where 1 carbon bonded to another 3 more carbon. Silicon dioxide will be found in sand, and then need to know that their properties also. Yeah, so need to know like the boiling point, melting point, electrical conductivity. Yeah, so all these properties are all in your school notes. So this one just have to study it. So all this important. Okay, then graphite need to know that it's actually carbon layers, so they can slide. So that's how your pencil lead, the ink can actually get stuck on your worksheet because you slide. So 1 layer gets stuck on the worksheet, the other layer is still in your lead. So your lead gets shorter and shorter as more and more layers get slide out. Okay, so over here, likewise for the MCQ, I let you try on your own. Oh, by the way, just to do a quick recap, what is allotrope? Do you all know what's allotropes? Anyone knows what's allotrope? No one knows. It's in the syllabus though. Okay, so allotrope means it is the same type of atom, but different structure. Very rare it will come out. It's like you seldom see it, but it's still within syllabus, so it can be tested. Yeah, so that means like same atom, just that you arrange it differently. So this one, the 2 MCQ, I leave it to you to try on your own. For question number 3 is just exactly what I went through, right? Then the alloy thing. Yeah, so question number 3, can you just refer to the notes in front? You just copy everything in. I even draw out for you already. So you copy the drawing and the explanation. Just work forward. So this one should be no problem. I move on to the last page. Chemical formula and equations. Okay, so in this topic, right, need to go and study all the chemical formula. I think the more difficult one to remember is like what? Nitrate, sulfate, carbonate, all those. Yeah, so how to remember that, right? By right, actually just memorize by heart. But in case, sometimes in exam, like sometimes what very stressful environment, like silence, and then like time constraint, and like need to do fast. Then sometimes you might blank out during exam, right? Like you know that you studied, but then you forgot. Yeah, so there is a backup plan for you, but I hope you don't use this because very time consuming. So how to memorize nitrate, sulfate, phosphate, and all? You go by this mnemonic. Can you follow me and copy it down? Nick, the camel, ate, supper. Ah, no space. Wait, I need to shift. Maybe I scroll up. Is there some more space on top? Yeah, I think above will be better. Ate, supper. You follow my caps and small letter, okay? No, this one is to how to memorize the chemical formula if you blanked out in exam, like nitrate, sulfate, phosphate, and all. Okay, so if you copy this sentence, right? So mainly my focus are the capital letter words. The eight at all these are just like connection words. Okay, so I assume that Phoenix is like a place name. Okay, so for Nick, of course, this is to memorize the formula for nitrate. Camel is for the formula of carbonate. Supper is the formula for sulfate. P is the formula for phosphate. Okay, so how does this mnemonic help you to recall? Is mainly by, this is very time consuming. That's why I feel that you memorize, but this one is like a backup plan in case you blank out. Yeah, so you count by number of consonants and vowel. You copy down first, then I explain to you. Okay, so how does this work? So for example, if I want to recall what's the chemical formula of nitrate, like study liao, but cannot remember at exam, so you go by this. So for the word Nick, how many how many consonants are there? Consonants means not A, E, I, O, U. So that means it will be like N, C, K. There's 3 consonants. So 3 consonant means 3 oxygen. So I write O3. Next, how many vowels? Nick only got I. I means 1. So that means, and the charge it must be negative. Okay, so all the ATEs, all of them must all be negative charge. Yep, so that's why it should be negative. So that's why if it's 1 vowel means 1 negative. So minus. So that's the chemical formula of nitrate. Okay, let me demo one more time for carbonate. So for carbonate, how many consonants are there? Camel is CML. 3 consonant. 3 consonant, 3 oxygen, O3. Then next, how many vowels? Camel is A and E. So A and E is 2. So that's why it's 2 negative. So carbonate is CO3, charge of 2 minus. Then you do likewise again. Sulfate, how many consonants? Supper, SPPR, 4 consonant, O4. How many vowels? UE, 2. That means 2 minus. Likewise for the last one, Phoenix, PHNX. Yeah, so it's 4 consonant, then it will be 4 oxygen. How many vowels? OEI. 3 vowels, 3 minus. Then ta-da, you get a formula now. Yeah. But this one you can tell it's very consuming, like time consuming. You count. Yeah, in exam, you like count. I don't think you have time to finish your paper. So this one by right you should study at home. This is just a backup plan. Okay, so these are some of the tips and tricks that we teach at tuition. Yeah, that usually school won't teach you one. Okay, so then so next is need to know for chemical equation, you need to write state symbols. So need to remember the solubility table. So for solubility table, just to go through with you that for especially for salts, how do you know what salt is solid or aqueous? You go by this SPAN. As long as the salt got S, which is sodium, P for potassium, A for ammonium, N for nitrate. As long as got SPAN, span, that means you confirm you put aqueous. Okay, all of them guaranteed aqueous. But calcium, nitrate, nitrate. And then potassium chloride, potassium. So as long as you combine anything with SPA or N, right, confirm it is aqueous. Next, for sulfates. How to remember sulfate? Is it aqueous or solid state? You go by S for sulfates, S
For soluble, so most sulfates are aqueous except the 3 sciences. So the sciences are the exception. So usually in upper sec, what are the 3 sciences that you learn? You learn bio, chem, physics. Correct? So for the bio, chem, physics, what are all these atoms? So it will be, you add in letter A first, then add letter B. Can A, B. So alphabets, you write letter A first, then add letter B. But I do in sequence also, like bio, chem, physics. So it's B, then C, then P in alphabetical order. Then it's AAB, the second alphabet. Yeah, so that means only these 3 are solid state. Any other sulfate should be aqueous state. That means, example, barium sulfate, you write bracket S. Calcium sulfate, you write bracket S. Then any other sulfate, like maybe iron sulfate, you write bracket AQ. Okay? Then another one, it is the chlorides. So how to remember chlorides? Chlorides go by, you wear cap. You wear cap. So cap, it means chlorides. Yep, so all chlorides are soluble except these 2. So usually the ones that I point out, right, is usually the exception. So only silver chloride, this one is solid state. P means PbCl. P is also solid state. Yeah, so that means CaP, all chlorides are soluble except A and P. A for Ag, P for Pb. Okay. Okay, then next it would be, there's also carbonate, right, in the list. Okay, right over here. So for carbonates, right, it's very straightforward. Carbonates, you just follow the norm. What do I mean by follow the norm? If your carbonates has span, like sodium carbonate, potassium carbonate, ammonium carbonate, don't have nitrate carbonate, because both are negative. Yeah, so as long as it's SPA with carbonate, then they will be aqueous. If not, it will be just insoluble. So most carbonates are usually solid states. Yeah, except SPA carbonate. Okay. Yep. Then lastly, there's also like the hydroxides. Yeah, so for hydroxide, it's also same thing as carbonate. Hydroxide is also follow the norm, and most of them are solid. Yep, so that means only if it's like, okay, maybe let me write, wait, let me just write down this, except, because this time I got extra carbon, calcium, SPCA. You know there is this animal foundation called SPCA. So sodium, potassium, ammonium. So the SPA is still the same as just now. That's SPA. The SPA is still the same. SPA. The C over here is calcium. Yep. So all of them are solid state except sodium hydroxide, potassium hydroxide, calcium hydroxide, ammonium hydroxide. These will be aqueous. Can, because SPAN is always aqueous. So that's how you can remember. Yeah, so it's like simpler way to remember lah. Tips and tricks. Yeah. Okay, so then yep, so for chemical equation, there's that symbol, must balance the equation. Actually, for chemical equation, need to like really practice lah. You practice more, then you'll be better at it. Yeah, so like just 2 more practices. Okay, then next is for ionic equation. Ionic equation, there are actually shortcuts also, like this kind of memorizing, like sulfates and all. Okay, so I shall move on. So for those online, if you are not done noting down, you take a screenshot. I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so for ionic equation over here, the shortcut would be you first identify if it is a precipitation reaction or is it a neutralization reaction or the rest. So the rest is usually this kind. You must write out, then cancel the spectator ions. Okay, so for precipitation and neutralization, got shortcut. So for precipitation, okay, what exactly is precipitation? It means that I mix 2 aqueous things. Then in the end, right, I can actually get solid precipitate. That's why the name is called precipitation, because you can get precipitate. So precipitation is very iconic one. It's always aqueous get solid aqueous. So whenever it's precipitation, don't write spectator ion. You will spend a lot of time. You need to write chemical equation, then write out, then cancel spectator ion, then write the final answer. It's very time consuming. If it's precipitation, right, the shortcut would be you just write out what's your precipitate. For example, like here. Can you see this aqueous get solid aqueous? I don't need to do all this steps. I can immediately get the last answer. Why? First, you just write out the precipitate first. So you write the precipitate, then work backwards. So what do I mean by write the precipitate? So like example, if this reaction, I know that, oh, my precipitate is this. Can you see? This is the solid ma. So if this is the precipitate, you write down the precipitate first. So I write down BaSO4 bracket S. Then I work backwards. What is barium sulfate made out of? Barium sulfate is made out of barium and sulfate. Correct? Then sulfate, just now you memorize, it's a supper. So it's SO42 minus. Then since you know that ionic equation, they already said must be in ions. So Ba change to ion. So you check periodic table. Ba is in group 2. 2 is 2 plus. That's why now what you do is that since precipitation is always start from aqueous, that means the starting must both be aqueous. Done. You see, so fast. So you just need to identify the solid, then just work backwards. Then make sure that you count out one barium, balance. One sulfate, balance. Done. So you don't really need to write so long, cancel, spend a lot of time. Yeah, because time consuming in exam. Yeah, so yeah, time is precious. Done. So this is a shortcut. Next, for neutralization, the shortcut is no matter what kind of acid, like is it like 1H or 2H or 3H, like be it HCl or H2SO4 or H3PO4, no matter how many H the acid have, right, the answer confirmed is always the same. H plus OH minus, you get H2O. But this one is only true if your neutralization, right, both are equals. That means it must be like alkali that is soluble, acid that is soluble. Must be, so that means the criteria is that they must all start from equals first. If got solid or what or liquid, then you cannot use this shortcut anymore. So if it's like got the liquid or gas, then you have to do as per usual, like what your school teach you, like write out everything that is equals. So only equals, you split up there. Can you see? Equals, you split up. Equals, you split up. If it's solid, liquid, or gas, don't split up. Solid, liquid, gas, you copy exactly the same. Then for the ones that are similar, then you check out which one can cancel out. So in this case, the copper and copper exactly the same, right? Cancel. Oh, the nitrate exactly the same. You cancel. So what's left? You write it in. So this is the other chemical reactions. Yeah, so the rest really no shortcut. Okay, then the practice question here, I leave it to you to try out on your own. Yeah, so you give it a try, then you check the answer key that I will be providing. Yeah. Okay, so so that's all for the lesson for today. Thanks for staying back for the extra part. Okay, so hope that you have benefited from the lesson for today. So I think just now some of you were like asking about like if like interested to sign up for tuition, then how? Yep. So just stay, if you're interested in tuition, you just stay in the OVERMUGGED O-level Telegram channel. So next week there will be an announcement on early bird sign up. That means there will be actually like benefits. Yeah, so like you will get to like select the classes and all. You will get extra freebies also. Yep. So if you can confirm that I want to sign up tuition for next year Sec 4 in September, then yeah, that will be get all the benefits. But if you say that I want to see my result how first, then I decide whether I want to join tuition. That's October. Then if you register with us like after exam result out, like in October, then we will actually give you a free trial lesson. That means you get to sit in our lesson to experience how the lesson is, and then get to know who is your teacher by then, yeah, your tuition teacher. So you can see the teacher's vibe, whether you like his teaching style or not. If you don't like, maybe you can try change to another teacher or something. Yep. Then after that, then you then sign up. Yep. So that means you can still attend and try out first. Don't need to have any commitments yet. Yep. So then if you sign up with us in October, we'll tell you to come down in early November for the free trial lesson. Yep. Then the official tuition depends on teacher. Some teacher will start in November, some teachers start in December. Yeah, like that. Okay, so then maybe is it all right that you help to like scan this QR code to like give us some of your feedback? Yeah, so if you appreciate our time in giving you the free lessons, then can I appreciate you like if you appreciate, yeah, then maybe can you like spare out a bit of moment of your time to like help us to fill in this survey, yeah, so that we can like have lessons that is like of better quality for you, even for like the next few lessons, even like for the chemistry second session. Yeah, so chemistry second session, it will be actually on the other chapters that I haven't covered today. Yeah. So if you want to sign up, you can still sign up for the slots. Yeah, there are still online slots available. Okay, then after you all have filled in this form, then I will be giving you all the answer key link. Yep.
Yeah, so for any of you who would like to receive all chapters, like the complete set of notes, yeah, you can feel free to head down to any of our OVERMUGGED centers at Bukit Timah, Marine Parade, or Serangoon to collect the hard copy of the revision kit. Yeah, so inside there will be the notes of all chapters tested for your end of year for all subjects that is English medium. Yeah, so that means got math. Sorry, don't have humanities. Yeah, because our humanities only the actual tuition, don't have the revision kit. So we have for math, science, English. Yeah. So if you want, you can head down to the centers to collect. Then for those of you physically present here, if you want later, you can just collect before you leave. Yeah, you can collect for your friends, your cousins, your siblings also can. Jake, I don't have the writing I clear off already. So I undo. No problem. Then after you are done filling in the form, then here's the QR code for the answer key. I think most of y'all have it already because I sent it in the Telegram chat also. Yep, so wait, can I make it smaller? No, I can't make it smaller. Wait, let me see whether I can shift. Maybe like that. On top. Or maybe Jake, I erase a little bit on the left side can. Should be okay, right? Like that. Okay, then like that, at least it won't block the QR code. Yep, so you can scan the QR code for the answer key. Yep, so I'll recommend that you finish up the worksheet and then yeah, check with the answer key provided. Yeah, then like do more practice lah. Then hopefully can help improve a bit more before your exams. Yep, so done. That's all for today. So yeah, I hope that you have benefited from the lesson today. Yep, so I'm Miss Felicia, so signing off then. Bye-bye.